Hi, it's Alan from Crashtest Security. In this video, I will tell you how to choose a cybersecurity tech stack. So let's get started. The evolving nature of cyber attacks has necessitated an overhauled defense deterrence for cybersecurity. Choosing the right cybersecurity tech stack helps administer security from external threats while ensuring you adopt the tools and platforms relevant to your application and related workflows. As with any other form of technology, cybersecurity requires a combination of security practices, the approach, and software tools, the tech stack, to ensure a proper security posture. While a security practice is the strategic plan to identify, mitigate, and counter security threats, a tech stack essentially involves various tools and platforms, ranging from simple antiviruses and firewalls to sophisticated tools like DNS filters. The cybersecurity tech stack acts as an enabler to your security practices by providing an architecture framework of various tools to detect and mitigate vulnerabilities. Also, it might be useful to learn more about the latest cybersecurity trends for businesses. Cybersecurity stack benefits and advantages for your business. Adopting a cybersecurity tech stack additionally includes components that protect your digital assets, network, core services, operating system, databases, web servers, and custom web apps from cyber attacks. To run your applications and websites effectively, these components should be properly coordinated to ensure optimal workflow delivery while leaving zero gaps in the cybersecurity tech stack. The right cybersecurity tech stack is based on your organization's risk profile and is customized to handle threats and attacks preemptively. Your security stack helps you efficiently create a robust defense program by addressing security concerns across the entire threat landscape. Additionally, an organization also realizes cost reduction of data backup and disaster recovery by dedicating resources to identifying and handling potential and even active attacks. Securing applications differ with use cases, depending on the runtime environment and backend code. First, let us take the reference of the two most common runtime environments, PHP and Nodage. While you can leverage out-of-the-box best practices for security for a PHP-based application, those are often not enough. Instead, it is recommended that you adopt a holistic approach of hardened testing and specialized tools focused on working with a PHP-centric application tier. On a similar note for a Nodage application, it is essential to note that securing such an application often starts with securing the JS engine apart from removing vulnerabilities across all layers: application, platform, server. Moreover, PHP and Nodage differ in generating output and exposing their functionality to the web. For example, while PHP has a session management module, Nodage comes with an HTTP web server module. As a result, the right multi-layered approach to security would factor in vulnerabilities within the respective modules and their mechanism to generate output. A security tech stack should always be factored in considering the application framework with a proactive approach. Cost of development. Every tool on your technology stack adds to the cost of developing and maintaining your apps. As a result, a considerable budget often supports significant application developments. While this budget supports the most sophisticated security technology stacks, you should also consider the costs of running your security solutions in the long run. A security stack with an array of different technologies also necessitates the recruitment of specialized personnel. Therefore, keeping your security stack minimal and straightforward is essential to reduce your application's overhead of administering security. Additionally, discussing security needs and budget allocations with your developers during the planning phase is necessary to determine your application's most appropriate cybersecurity tech stack. Scalability. With your application's users, data, and functionality growth, your security stack should scale and evolve to match your application's changing needs. In addition, data protection should now include remote work and mobility components with the advent of remote and distributed computing. As a result, you should review your firm's long-term architectural strategy and approach to threat detection as you select your security tools to ensure the stack covers all future expansion plans and endpoint devices without disruptions. Time to market. Time to market, TTM, is highly crucial in an agile and DevOps model on which a minimum viable product, MVP, is conceptualized. Your choice of a cybersecurity tech stack significantly affects development time, since most of these tools are designed to provide periodic fail-safe checks. More so, the perfect security layer should not slow down your applications during runtime. Even if you are not delivering an MVP, An overly complicated security stack may dull the user experience by making the application heavier. Keeping your app security stack as minimal and relevant is always recommended to maintain the optimum application performance as a best practice. Staff technical skills and abilities. Adopting technologies that your staff is already experienced and skilled in is always a wise decision. Different security tools require different skill sets to operate with various solutions created for different frameworks and runtime environments. Therefore, assessing your security staff's knowledge, competencies, and accomplishments can give you a clear picture of your team's skill sets. It is also essential to develop their knowledge through regular training and certification programs, to be aware of recent technological advancements and threat scenarios, and easily spot anomalous behavior or suspicious activity. However, thorough training to keep the staff updated from a security perspective can often get overwhelming and result in budget overruns. In such scenarios, an organization can benefit from security solutions like Crashtest Security, which offers vulnerability scanning software accessible by developers and security staff for all levels. Third-party technological dependencies. Every application in a modern business relies on the functionality of third-party packages, components, and libraries. Therefore, embracing such a model is crucial to agile development, since developers focus on creating core application functionalities while leveraging standard building blocks from trusted third-party libraries. However, this model complicates the security landscape as it increases the attack surface while introducing vulnerabilities susceptible to attack vectors. Therefore, it is advised to map out all dependencies of an application and architect the right stack to handle any threats from third-party vendor libraries as a best practice. The right combination of tools with an effective security program removes vulnerabilities across all application layers. Even with a diverse technological landscape, you will need to limit the number of tools in your stack for faster workflows, and as a result, keep a potential attack surface to the minimum. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.